So today we're talking about triangles, right? The common core again is G for geometry, CO for congruence, and it's like number 10 on the list because it's triangles. It says basically, prove theorems about triangles. All right. There it is. Common core, G for geometry, CO for congruence, 10. Prove theorems about triangles, all right? So, number 1. So if we take a look at this triangle, there's really a triangle within a triangle. There's really there's 3 triangles. Girls, Nicole, I want you to go back and sit there, please. Okay? So classify by triangles, by its angle. So if there's really 3 triangles in here. So first of all, if I take a look at the big angle, there's a right angle there. So EHG, let's see, EHG could be a right triangle, right? It's just a right triangle because we want to prove it by its angles, not by its sides, but by its angles. All right, EHF, that's that one. Now we got to do it by its angles, right? So let me see if I can figure out some things about this. Well, that's 160. I know that angle's 120. How did I get the 120 there? Why did I know that was 120?
Straight angle.
Straight angle. Nice job, Claire. 180 degrees, straight angle. So what would be this little angle here? Emma, say it. 30. Because they all have to add up to 180. So if that's 30 and that's 30, right? Then, and that's 120. If I do it by its angles, then this has got to be an obtuse triangle. You guys see EHF. Let me highlight it. EHF, I'll just highlight it so you can see it. EHF is that one there, highlighted. So EHF has to be an obtuse triangle. Okay. HFG, let's see, HFG. Okay, let me highlight that one too so you can see what that one is. Do this one in orange, okay. Okay. So by its angles, well, 60, 60. What's this angle up here? 60 has to be for a couple of reasons. One, it has to add up to 180 plus that makes, you see the box for 90, right? So what's the name of that triangle? So you got it, actually acute is correct, but we're going to be more specific and call it equal angular, okay? Totally right though, Kurt, okay? I'm going to call it equal angular because all the angles are equal. We could call it equilateral, but we won't call it equilateral because we want to specify it by its angles, okay? See the difference? It could be equilateral, but since we're talking about all its angles, we're going to call it equal angular, okay? All right, number 2, now by its sides. So we're going to do this one, ABD, ABD. ABD is the big one, right? ABD, let's check that out. ABD is the big one, okay. ABD, well, wait a minute. Now remember, I am not an artist, but believe it or not, it is 7, 7, right? Wouldn't that be isosceles? Because these two have to be equal. It doesn't really, if you go 5 plus 2, you get 7. 7, 7, so I'd say isosceles. Okay, because we're doing it by its sides, right? ACD, let's see, let me check it out. ACD. ACD is that. Well, I know. Say it. Scalene. That's what you mean to say. Yeah, because if this is 5, you see a little dash here, little 5, that means this side also has to be 5. So this triangle, my yellow triangle, ACD, I got 5, 2, 7. They're all different, so Katie's right. It's a scalene, okay? And then finally, we'll do the last one up here, ABC. We'll do that. ABC is this one here in orange. 5, 5, 5. So it's got to be 5, 5, 5. It's got to be equilateral. Got it. Perfect. Okay. All right. Now, again, I don't think today is going to be that difficult for us. Example 3. So if you've got this little dash here, remember these little dashes means these two are equal, so it tells us too JK is equal to L. Okay, so let's just set them equal. Yeah, thank you, Katie. So let's just set them equal. If this little dash here, we know this side's equal to this side. So if we want to find the length of each side, let's find x. So let's set them equal. Let's go 4x minus 1.3 equals x plus 3.2. Put a 1x there. That's going to help me, right? Put a 1x. That's going to help me solve. Okay. So let's solve. All right. I've got x's on both sides. Let's go minus 1x, right? So I get a 3x minus 1.3 equals 3.2 plus 1.3. Am I going too fast? I'm okay. Plus 1.3 plus 1.3. I'll slow down for a second. So I set them equal. 4x minus 1.3 equals x plus 3.2, and then I'm going to solve. So minus 1x minus 1x. Got a 3x. So let's see now. I'm going to go ahead and add 1.3. So 3.2 plus 1.3 is a 4.5. So I got a 3x equals 4.5, right? Divide by 3, and x is a 1.5. Okay, good. That's not the answer, though, is it? It's not the answer because the question is to find each side length. Okay, so we haven't done that yet. So let's plug the 1.5 in. Let's put it here. So I'm going to go 4 times 1.5 minus 1.3. Okay, so let's see what that is. I got 4 times 1.5 minus 1.3. I get 4.7. So this side's 4.7. Okay, I'm going to circle that because that's one answer. I put my 1.5 here also into that x.
Which is also 4.7.
You're way ahead of me, Katie. I like that. 1.5 plus 3.2. Yeah, it has to be because they're equal. Why am I doing all this work? You're right, Katie. If they're equal, it's got to be 4.7. Why am I even plugging it in? Thank you very much. Duh. And then plug it in up here, right? So I'll take and plug it in for the x. I'll go 5 times 1.5 minus 0.2. 5 times 1.5, 7.5 probably, yeah, minus 0.2. And I get a 7.3. Alright. Pretty easy. What do you think? Thumbs up, sideways, down. What do you think? Yeah, give me a show of hands, okay? Pretty easy? Okay. Alright, last one, number 4. So what do you know about angle A and angle C? They're not equal, by the way. What do you know about angle A and angle C? Don't say they're equal.
They equal 90.
They equal 90, don't they? They have to equal 90. I know that the measure of angle A plus the measure of angle C has to equal 90. It has to. Because if the whole triangle's 180 degrees and 90 of it's used here, these two have to add up to the other 90, okay? So we're just going to go our 7x plus... Yeah, it's not really confusing. 7x plus my 6x minus 1 equals 90, right? If I add the x's, I'll get a 13x minus 1 equals 90, right? Plus 1, 13x equals 91. I don't know. Oh, it does go in evenly. Divide by 13, it goes in evenly. It's 7, okay? But that's not the answer, is it? That's not the answer. We need to find the angle. So take the 7, plug it in there. Take the 7, plug it in there. 7 times 7, that's easy. That's 49 degrees. 6 times 7 is 42. Minus 1 has got to be 41 degrees. How's that? Okay, so let's write this down on our homework sheet. Page 219. 119 odd, 52 to 58 even.